Hey everyone, and welcome to this new lecture in coordinate geometry. And like I said in the previous lecture, that we would be going through lines and angles in this lecture. So basically, what you have in front of you over here in the diagrams shown in the slide are two parallel lines. This L and M are basically known as parallel lines. A parallel line is any parallel lines are any lines which remain in the same distance with respect to each other till infinity. If you extend this over here and extend this over here or in this direction, L and M would have the same distance between them, which by that I mean the distance over here. Now this is what a parallel line is. If you have a parallel lines with you, and if you have a line that crosses these parallel lines, so these lines are also known as coplanar. Coplanar means same on the same plane. That is coplanar means. So since these two lines are going to be on the same plane, these will be called coplanar. And this line, if it cuts these two lines, the properties of these two lines have to be, they need to be parallel and they need to be coplanar. And then if this line crosses any two lines which are coplanar and parallel, which share these two properties, this line is going to form some angles. Now this line will form basically 8 angles over here, as you can see over here. Now why do I have this as 1 and this is 2 and not this is 2 and this is 4 and then this is 5? Well, I'm going to talk about that as we move forward. So when a line crosses two parallel lines and which are coplanar, 8 angles are formed. 8 angles are formed which have different names and different properties. The type of angles that are going to be formed are known as corresponding angles, alternate interior angles, alternate exterior angles, and interior angles on the same side of the line, this transversal line. So how do we deal with these angles, and what is the sum of these angles, and how do we find out any missing angles? So we'll get to that, but before that we will go to the different definitions of the different types of angles. We'll start with the corresponding angles. So corresponding angles are exactly what the name tells you. They correspond to each other. They, if you, like I've told you before and before, you don't have to rote learn this stuff. You just have to make the concept of it, get your concepts clear, and then it would be easier for you to understand, and you won't have to actually memorize this, and you would know this for what they are. So if you look at this, these two lines over here, and this line passes through them, since as you can see 1 and 5 over here are corresponding. Why? Because these both are on the same side, on the same position, relative position with the intersection of this line on these two lines. Like they are basically 8 angles, so you're gonna get 4 pairs of corresponding angles. Over here 1 and 5 are corresponding angles, 3 and 7 are corresponding angles, 2 and 6 are, and 4 and 8. If the way to find out this is that you just look at one of the angles formed over here. So when you looked at one of the angles formed over here, you numbered them 1 2 3 4. Then you look at the same position on the other side. For example, if you look over here, you look at angle number 4. So angle number 4 is on the bottom of this line and the right of the transversal. So you look at the you try to find the same angle in the next group of angles. This is number 8 over here. If you look at this is on the right side. You will just have to look at over here. There are two angles on the right side, 6 and 8. And once you're done with that, on the bottom of this line, that is M over here and N over here, so that is 8. So this way we can find out the corresponding angles of any line that passes through any other two lines. Just like that, if you have to find out the corresponding angles, that if there are any corresponding angles for the angle number 3, it is on the left side of this and on the bottom side, on the lower side of this M. So we look over here, T, there are two angles on the left side of T, 5 and 7, and there's this one angle on the bottom of N, on below N, that is. So the 3 and 7 are going to form the corresponding angles over here. Now the good thing to remember, that the important thing to remember over here is that the corresponding angles are equal. So 3 and 7 are equal. their magnitudes are equal. Just like that, 1 and 5 are equal, 2 and 6 are equal, 4 and 8 are equal. So if you have 3 angle over here is going to be 51 degrees, then 7 over here is also going to be 51 degrees. This really comes in handy if you have some of the angles over here. If you know the angles over here, and if you don't know some of the angles over there, you can find those out. If let's just say you have all the angles over here and some missing angles over there, you can find those out through here as well, and vice versa. So remember that corresponding angle correspond to each other with respect to position and with respect to their magnitude, their value. So the corresponding angles are the angles which are close to each other, which are in the same position to each other relatively, and they also have the same value with the same magnitude of the degrees. One thing other I like to mention over here is that although you can see that M and N are actually not parallel over here, like the distance between M and N is increasing over here, it is more over here than it was over there. But this property only holds for parallel lines. M and N are, although the drawing does not show this, but M and N are considered to be parallel over here. So that is why this corresponding angles will be equal, and this is the property only holds for parallel lines. Just wanted to correct myself over there. So moving on, now we have alternate interior angles. Now I'm pretty sure everyone knows what interior means, and I'm pretty sure everyone knows what alternate means. Over here the same conventions are being followed. Both the lines are parallel, both the lines are being transversed by this one particular line which has red in color. So now after this is done, there will be 4 angles which will be formed. Of course there will be 8 angles which will be formed, 2 over here, 2 over here, 2 below it, and 2 above it over here, and 2 below it over here. But of course we're not going to talk about that. We are basically only going to discuss the interior angles over here. We go through the exterior angles afterwards in the next slides. So when this scenario is that you have 2 angles, 2 parallel lines, and another line cuts it. So the angles which are interior, that is on the inside, and which are alternate to each other, that is on the opposite side of this line, like 5 and 6 are over here, 8 and 7 over here. So these two angles are easily equal. So 5 and 6 will be equal, and 7 and 8 would be equal. So this is, like, I mean, if you draw this, the best way to do is that you take a piece of paper and you have a protractor with you and rule, a 6-inch rule or something, and then you draw these two lines, you transverse it, and then you start measuring it. You draw these two lines, you transverse it, and then you measure this angle and this angle, and it will come, it will show you that both of these angles, that this pair over here is actually equal. So that is the best way to do it, because that is the best way to make sense of it. Otherwise you have to basically learn this. Over here, if you look over here, since, well, you know, let's just concentrate on that one. So I suggest that you draw these so that you can remember this, so you can actually find out which angle is equal to the other one. So moving on, alternate exterior angles. Okay, so first of all we have to understand what exterior means. Exterior basically means on the outside. So just like that, internal meant on the inside. Like over here in the previous slide we saw these 4 angles are on the inside of this whole arrangement over here. And just like that, the angles on the outside are going to be called the exterior angles. So this angle over here is A and B, and G and H are called exterior angles. And alternate exterior angles basically means, alternate over here means on the opposite side. So this line crosses these 2 parallel lines, so it's going to form 4 exterior angles, and then it's going to have some alternate exterior angles. That means that A and H over here are basically going to be alternate exterior angles, and these two are congruent. So just like that, over here we have the internal and interior angles, that is 5 and 7, 8 and 6. And since these angles, there's some angles on the opposite side of this line, like 5 is on the left side and 6 is on the right side, so that is why this is going to be called an alternate interior angle. Otherwise 5, 6, 7, 8, all of these are just interior angles. Even 7 and 6 are interior angles, but for the property to hold, for there to be pair of angles, so if there to be any property between angles, it has to be noted that they need to be on the alternate side so that the properties could hold. Just like that over here, the all exterior angles we have A, B, G and H. In order for the properties to hold, we need to see that A and H are on the opposite side, just like B and G are on the opposite side, and that would make the interior alternate exterior angle. So these properties over here, which are written over here, these are all only for the alternate exterior angle. And the way to know that is really easier to it's really easy to know which one of these are exterior angles, and it is really easy to know which one are alternate angles, and that way you can find out which one are alternate exterior angles. So moving on. Now we come to the interior angles on the same side of the transversal. We talked about the alternate interior angles. We talked about the alternate exterior angles, but there's one other couple of pair of angles that we see forming when we have two parallel lines being transversed by one line, and that is basically this pair over here, the interior angles over here, D and F, C and E. If you look closely over here, let's derive something. We found out that A and H are equal. We found that out in the previous uh, slide, alternate exterior angles. So both of these are alternate exterior angles, and A and H are equal. Now we know that any angle on the straight line is equal to 180 degrees. So that would basically mean if A is, let's just say, 110, H is 110, so F would be 70. F would be 70. Of course, we all know that. Another thing that we know is that opposite angles that we studied over here, which we call vertically opposite angles, these are equal. So that way we know that A over here and D over here are equal, which basically means that if A is 110, then D is also 110. Another way to do that is, if A is 110, so B would be 70. Why is that? Because it is on a straight line. We are looking at this line over here, this orange line over here. Now B is 70. So if you look over here, this line over here, so B and D are going to make 180 degrees. So B would be 70, so D would be 110, which goes on to prove that A and D are equal. This is also because A was 110 and D was 110. We already calculated that F is equal to 70. So what does this tell us? This tells us that D and F, which are interior angles on the same side of the transversal, that is, this not D and E. We know D and E are equal, but what are D and F? What are C and E? We already talked about the alternate interior angles. Alternate interior angles are on the different side of this red line, which would be D and E. These are on the same side. What property holds for them? The property is that two angles, interior angles, which are on the same side of the line, are going to make a sum of 180 degrees. That is, D and F are total going to make 180 degrees. So D and F, I just proved to you how it's going to make 180 degrees, because H and minus F is equal to be 180 degrees, and just like that B minus D is going to be 180 degrees, and it's on a straight line. So since it is on a straight line, it's going to make an 180 degree angle. So we just went through all of the angles that are formed. Just remember a couple of terms. What does interior mean? What does exterior mean? Exterior is anything beyond, above this and below this parallel line, that is exterior. Interior would be anything which are enclosed by these parallel lines. This line and this line, everything in between is interior, and everything beyond it is exterior. Alternate would mean on the different side of this line that cuts through the parallel lines. So first of all, remember, the parallel lines are lines which are coplanar, and which the distance of whom does not decrease if you extend. It does not increase or decrease if you extend them. If you cut a line through them, you're going to have 8 angles with you. Some are going to be corresponding, some are going to be alternate. Remember that whenever you start with the basic ones first. Whenever you have questions with this, start with the basic, most easiest angles. The most easiest that I find are this one, the vertically opposite angles. So whenever you have, like over here, if you look over here, so you're going to see that F and G are opposite, so they're going to be equal. A and D are going to be equal. B and C are going to be equal. E and H are going to be equal. After you're done with that, so then you can find out alternate interior angles. We know the properties of alternate exterior angles and the interior angles of the same side. Remember one thing, that the only way you can get a hold of this, the only way that you can actually know this for the rest of your life, like if you understand, make this concept right now, you won't have to again like I said, rote learn, or you won't have to once again memorize this or go through them. The only way to do that is if you make two parallel lines, and then you pass a line through them at a slanted line through them at a certain angle. Once you're done with that, you start measuring all the angles. You take a D as they call it, and then you start measuring. You first name all these angles, A, B, C, D, E, F, G, H. You measure all these angles, you write them down, and then you analyze. Like you're gonna find out A and D are equal. You're gonna find out B and C are equal, and then you write down the properties on the another side, and then you relate them. Once you're done with that, once you have done it yourself, once you've felt it, you've actually done it with your hand, you've seen that these angles are actually equal, and it's not just a theoretical thing, it's actually very practical, it's actually what you see all around you. That is when you're really going to understand the concept. That is when you really, it's going to really going to be embedded in your head, and you're never going to forget it, because you would have first-hand knowledge of this, and you would have, your concepts will be really solid, and you won't have to memorize the name, or you won't have to memorize the properties, since you would know that which angle is which, and which angle holds which property, and which angle is opposite to or alternate to or equal to any other angle. So thank you very much for watching. We are done with this part of the coordinate geometry. We're going to start with conic sections next, and I hope to see each and every one of you in the next lecture. Thank you very much.